Start recording here. So for okay, so we've got the nominal OSC 2028 thing. That's pretty ambitious and all that. You got 2026 goals. What are your thoughts on the scenery thereafter? Just quickly, like if you don't, then you don't. But think about it
I
because
do.
it's always good. Yeah.
Uh, After finishing the three priorities that I want to build, which are the
Mm-hmm.
freeze dryer, the reverse osmosis water treatment, and number three, the pot infrastructure in order
Mm-hmm.
to grow food just with a single pot and have all integrated.
Mm-hmm.
I would say just focusing on what already is on open source ecology wiki, the global village construction set, and be able to build teams in order to make that happen as fast as possible.
Mm-hmm.
So we're asking about 2032. That's what I understood.
Yeah,
And
2032 is a nominal schedule because the nominal schedule for OSC is Global Village Construction Set 2028, and then Open Source Technosphere. That's like a 6 year. I'm adding 8 years to 2028, which is like 2036, and that's nominally what I think about. 8 more years, we get major scalability happening, and Open Source Technosphere, just simply that things are open. Period.
correct. So I wouldn't change much about that goal that is already there. It's just building now in order to create these distributed enterprises
Mm-hmm.
and be able to. Of course, I want to achieve this by myself by improving the business model, by getting into near zero marginal cost on the processes, lowering the capex and lowering the
Mm-hmm.
OpEx, well, the operational expenditure.
Mm-hmm.
And by doing that, um, I have big hope that we're going to be able to get more students or builders in more concrete works in order to make this happen,
Yeah.
because that's the missing piece now.
Yeah, it is. It is. And when I think about doing what we do at OSC, that's about getting bodies in. That's I shared that already. We can talk about different products, but as we think about that, we have to be strategic. Also, what's going to get people in right now? What things that people can understand, relate to, so that the bodies start appearing, and all that. So that's the kind of general thought process. Okay, so for 2026, freeze dry process, reverse osmosis, integrated growing pot. So today, what do we do in the next 1.5 hours?
Understanding, I want to understand the infrastructure I need to have in order to be able to build this. And I know the last call we mapped exactly what machinery I need to build here at my hometown. We talk about a 3D printer, we talk about a plastic extruder, we talk about the pelletizer. Mm,
Yeah. So you want to focus the discussion on what infrastructure for freeze dry process, if that's the number one priority. So focus on that.
yes, just before that, I would like to understand the part of getting the kilowatt of energy
Hmm.
at 0.01, 0.02. That's already done 100%. That's not something we have to build.
That's open, like PV photovoltaic panels at the low cost are available, so we don't have to do anything. Now the only troubling spot for me, but even with those 1 cent per kilowatt hour costs, that assumes off the shelf inverters, which in my view are the weak link, and that's the thing that bothers me all the time, which which in the case of reverse osmosis, no, freeze dried. My first question is, are there available DC pumps, motors that can do the job of whatever the compressors and refrigeration motors, like all of that, does that exist in DC? That's kind of like my first pass. I was looking at that for heat pumps, and it turns out for heat pumps, no. AC is standard. Like the DC versions of that are super expensive, but that would be the first question to talk about. But so, do you want to? Are you asking to go through to reiterate the energy infrastructure requirement? So we should go through that first, or
I said I would say yes because that's the biggest point to make everything else feasible regarding cost.
I was
With
assuming that away because I'm pretty confident about that. So, I mean, it boils down to okay, we've got the freeze dryer, and we got to look at okay, what's the power consumption that the basic unit is if we design it modularly. How do we integrate the PV system with it? Like, say, do we want to go with 12 kilowatt inverters that we get off the shelf that are right now $1,000? Yeah, like I was just looking at that today. A friend sent me a link. $1,000 for a 12 kilowatt inverter. Now that's getting good. The only trouble spot there being okay, it's gonna break and then you're helpless, right? So that's the only thing. In which case, the only change in the plan would be how much do we invest into open sourcing the actual inverter, and if we want to get like not necessary at all for the economics, the energy economics we discussed already, because they were already based on off-the-shelf inverters that break. So I think we can be confident, but I think we may want to go through some numbers again, like in assumptions for the PV system. What's the lifetime that I assumed for the inverters? I don't think I assumed the 25 to 30 year 2030 for PV, but for the inverters, I didn't really account for the fact that they're going to break all the time. Like, but you don't know. It's like it could be 5 years, 10 years, it could be 1 year, So it's one of those things that are a thing that unless we have more control over any open source design around that, we're just at the mercy of those things, which we know they break. Like the PV, that's not going to break. I think that's a pretty proven track record of these things just lasting forever. Short of like maybe catastrophic events like a major hailstorm which destroys your panel system or whatever. But typically these things are pretty robust. Yeah.
if we go about the inverter, you mentioned that those could break, but how often could that happen? And honestly,
Yeah.
you're talking they cost about 1,000 USD
Yeah. Yeah. That's
each,
right.
but you get that kilowatt at 0.01 USD cents. I think that shouldn't be a biggest concern right now.
Yeah, I think we can wash away that argument, and I would propose we go straight to open sourcing the actual components of a freeze dryer today. But let's nominally take a look at 10 kilowatts, $1,000, right? So say we've got like what's the payback time of that for you getting free electricity from the sun? Well, 10 kilowatts is going to cost you $2,000 in PV, $1,000 in the inverter, let's say. The value that you're displacing, like if you're comparing it to the agricultural industrial rates that you have, which were what, 4 or 30 cents a kilowatt hour, if I remember,
Yes.
something to that effect. Like say it's like, even if it's for you it was actually 30, right? That was the relevant figure.
It's about, I'm on slide number 14. The agriculture cost, it's 0.039. The
Yeah,
industrial cost, it's 0.225. But I cannot use
22.
I cannot use the agriculture cost because doing freeze drying is processing, is not agriculture.
You have to go with industrial cost, right?
Yes.
So if you were to pay 20 cents so say you got a nominal 10 kilowatt system, how many days does it take you? Like say it costs $3,000 for the inverter and PV, 10 kilowatt hours. So 10 kilowatt times 6. So let's do this. So let's do a quick slide to document this. Slide number 1. But let's take a look at some of the basic economics of freeze dry. So let's just document that because that'll make us go more confidently forward here. So let's say just the big picture items. So we're competing with 22 cents energy, right?
Yes, that's what I have a reality here in Mexico, at least in Sonora.
Yep. With, let's just say, nominally about 20 cent per kilowatt hour cost, electric cost for industrial power. So let's look at what, like in a 10 kilowatt, let's say we design a freeze-dry food powder machine that's a module of 10 kilowatts. We're running that with 10 kilowatts of PV. So power produced per day with a 3K 10 kilowatt PV system. And I'm discounting things like mounting because we can do that very cheap and all that. So each day you get 10 times 6, so you get 60 kilowatt hours. So 10 kilowatts times 6 hours is the nominal average per day rate. And you got probably, in Sonora, you got, well, probably that figure maybe like 8 hours per day on average year round. Do you have that
Yes,
figure?
it's about 8 hours. Yes,
Okay,
average.
so 80. So you got 80 kilowatt hours per day. So if you're doing that for 20 cents per kilowatt hour, what is that? You're making $16 a day in electricity from that 10 kilowatt.
About cost, you're talking the Sonora cost or
Yeah,
the Consource Ecology?
Sonora cost would be
Yeah, the point.
80 kilowatt hours times 20 cents
Yeah,
per
point
kilowatt
20.
hour. So that's $16 per day electric cost.
And that's per kilogram processed, or what's
No,
our
that's just what you would be paying. So that's 80 kilowatt hours per day. What's the kilowattage per kilogram produced?
about 10?
We got about 8 kilowatt hours per kilogram of freeze dry.
Yes, it's about the water content of what you're freeze drying. It says an average of 6 to 10 kilowatts. So
Yeah.
8 sounds good.
You know, for grapefruit, what it is, because grapefruit is your first candidate.
I would say orange or grapefruit. Yes.
Mm-hmm. Yeah. Well, so 8 kilowatt hours, so you get 10 kilograms, gets you 10 kilograms per day, right? At $16 of energy cost.
Well, we're talking about 1 kilogram of final powder. When we talk about the relationship of fresh fruit into final powder, it's about 10 kilos of fruit goes into 1 kilogram of freeze-dried powder because of the water removal.
Yeah. But you mentioned that it's about 8 kilogram hours per kilogram to get you the freeze dried powder. So you can get 10 kilograms per day out of 80 kilowatt hours. Is that correct?
That's what I didn't get it. The 8 kilowatt hour and the final output of 10 kilograms per day. What's the relationship there?
Yeah, so we're saying that each day we have 80 kilowatt hours available from the PV array.
From the sun.
Yep.
Okay,
So this is the line above there. So 80 kilowatt hours.
got it. Okay,
Yep.
divided by 10 or by 8. Sorry,
Yeah.
that each final output of freeze-dried powder requires 8 kilowatts. That was your calculation.
Yeah.
Okay,
Yep. So you get 10 kilograms. And what's your selling price for that kilogram?
Mhm. On manufacturing costs would be about 12 USD.
Yeah, so um, there'll be 12 USD. I mean, the way the figures look, so if you used grid electricity, you're paying 16 kilograms. Yeah, you're paying, sorry, $16 for $120 of product. I mean, that is, tell me more about that. I mean, is that the reality? That's only 16 bucks and you get $120 out of it? Is that real? Or am I making stuff up here?
Where did you get the 120? So we talk about 12 the
Yeah.
price, then by 10 units of final powder, and you get 120 USD.
Yeah, yeah. Right. So
Well,
you got,
yes, because that's electricity only. We're not taking into account the fresh fruit, the labor,
mm-hmm.
and of course the cost of the machinery.
Okay.
But yes, if we're talking of the single unit of electricity, that could be a conversion fair to show.
Mm-hmm. Mm-hmm. Yeah. Um, what's the fruit cost there?
0.50 USD per kilogram.
Right. So you paid times 10 kilograms, you paid $5.
And that's not the farm gate cost. That's if I go to a packer and I want to buy a kilogram already packed, that would be what could I buy it from. But if we talk regarding getting it from my farm, I could easily get it by half of that, 0.25 cents
Uh-huh.
per kilogram.
Half from your own farm?
Yes.
Yeah. Okay. Um, and if we're talking about 1 cent per kilowatt hour, you're talking about making $16 more out of that 120. Um, largest cost of production. So do you have the number for the total cost of production for that per kilogram of fruit powder? Do you have those numbers? Because I mean,
Yes, I'm about to paste it there.
okay. Okay. So your electricity is way high, right? Because here it says $7, whereas for you it was 16.
Yes, the thing is, I use as the lowest the zero point zero 0.01 that we talk of achieving with the open source ecology system, and the 7.2 is the highest cost of industrial electricity. That's why it goes from 0.7 to 7.2.
Mm-hmm. But you're oh wait, 7.2 per kilogram. How come it's that high? Because we said in our model on page 1, we said for 10 we're looking at 10 kilograms. The cost there would be 16 in electricity. In other words, $1.60 per kilogram, right? And you have up to 7.2 per kilogram. So you're making assumptions like, oh, that's pretty very high electric cost.
Yes, but I don't have the specific reference now where I got the
Okay.
7.5.
Okay. So fridge, labor,
You're correct.
capital, milling. Uh-huh. Man, so if that electricity cost, so in our case, let's put, can I put a 1.6 there
Yes,
instead?
yes,
But for 1 cent, that would be like, it's going to be more like point 0.1. 10 cents per, 10 cents. Yeah.
yes.
I mean, that's true.
10 kilowatts, 0.01 per kilowatt. It's true.
Yeah. So that's at, and here we said about 20, about your cost. Yeah. Okay. Um, Before we go further, it's electricity is a big point. What's the realistic condition? So you said, okay, so let's change this here to 1.1 to 3.4, 4.4, 4.8 to about 5. So about $1 to $5 per kilogram. And selling prices, that's industrial or open source version. But that's still amazing if your sell price is $12. So whether you have open source energy or not, I mean, this still would make huge sense, no? I'm just looking at the kind of the bigger picture here. Is that the case, or are we missing something?
No, we're missing something.
Well, because you had a much bigger assumption for electric cost, but if it's indeed about 10 kilowatt hours per kilogram, that's the reality there. 8 to 10. So, um, in other words, the economics look great whether we have free energy or not.
It's not making sense to me about that without the innovation of electricity, this still makes sense on a 12 US dollar
I
per
see.
kilogram. Because honestly, right now, the per kilogram, it's all about 25 USD to 30 USD because of the cost of manufacturing this kind of powder. So what I pasted here, it was an assumption I got from chat, but there might be missing certain concepts of cost that they're not included in here, which is making this appear very feasible
Yeah.
even without.
Do you have the source chat?
Yes, let me share it.
Just paste it in like right here. Source chat. Let's track this down because if we got to understand that, because then we got to know what we're competing with. Because we have to have a problem to solve. In other
Yes.
words, because here the problem to solve has been reduced.
Yes. Okay.
So let's look into that. Okay, so let's see what what your thread was like. Freeze dryers and osmosis, sure. Yep, freeze dryer process. Okay. So your figure is way off on the kilowatt hours per kilogram powder. It's here we're saying 35 to 60. You're telling me?
You meant on the chat?
Yeah. Let me share my screen here. Let's examine what we've got here.
Yes.
So here I'm seeing freeze drying energy demand 6 to 10 kilowatt hours per kilogram of water removed. Using oranges. Okay. That's your. You told me it's not that. Oh, okay. This is the total energy is 30 to 60. Now that makes sense. 30 to 60 kilowatt hours per kilogram of final product. We're really concerned about the final product. If we've got 80 kilowatt hours available daily, we've got like, 1 or 2 kilograms
Per panel.
Yeah, let's say it's 50. It's like 1.5 kilogram a day. So in other words, it was $16 of electricity for about $18 of product. Okay, now that makes sense. So yeah, you're losing money if you got that kind of electric cost.
Yes. That's why it makes sense for me regarding.
Yeah, because you got 16 electric, you got your labor and other things, such as per kilogram. Labor is not too bad, but yeah, the process itself, capital. So there's you're losing money because the electricity is too much. All right, so free electricity enables you to do this lucratively. So realistically speaking, okay, so let's review this slide number 2. Electricity cost is going to be like a lot. It's going to be
You mentioned 60 kilowatts.
Yeah, per kilogram you had. I'm getting a little lost here, but the bottom line is. Let's continue on your chat here. Right. So here it's showing that at about 10 cents a kilowatt hour, you got like $5 costs in electricity, but you're twice that, so you're more than 10. You're more than $10 in electricity costs before labor, maintenance, capital recovery. Refrigeration and vacuum. So actually the machine depreciation, is that vacuumware? I'm not sure what that is, but milling, packaging, blah blah. Total OPEX is 1 to 7 to 10.
That's what I pasted on the work doc.
Yep. Right,
But
and your electricity cost was actually quite high. So it'd be more like, it's not that 7 cents. The 7 cents was, sorry, $7. That $7 comes from upstairs. It was where was the breakdown of right, at 12 cents it was $7, so it's like you've got almost twice that. So yeah, you're at like around $15 or so per kilogram. Yeah. Okay. Okay.
Yes.
So we pretty much, so that's the story I heard last time. So that makes sense again. And let's see, what's the bottom line here for per kilo exact costs? Yeah, I mean here you got, yeah, what if you're getting it down to like a few cents per kilowatt hour, cost per kilogram. Yeah, so it becomes highly lucrative. And therefore the question of, if we count the money and priority for this, what exactly are those numbers? What's the throughput of a, say for a 10 kilowatt? Let's take a look at, how about we take a look at this now? Take a look at the standard off-the-shelf machines and what kind of throughput they have. Do you remember any of those figures from before? Like,
I didn't got any of those in the chat. There was some references,
yeah.
but I didn't get any technical
Okay.
details on each.
So let's take a look at. I mean, they're quite expensive. Harvest Right freeze dryer, vacuum freeze dryer, 70,000.
That's why I was hoping to make our own instead of buying from off the shelf, because
Yeah.
that makes it really hard on capital.
Yeah, it looks. Okay, so the next question is, for the smallest, 70,000 for something that makes about 10 pounds.
Per day,
Okay,
correct?
so yeah, so forget about it. This is, I think, the case for open source. Wait, what is this food freeze dryer machine budget for $1,000? Oh. Yeah, anyway, the prices look pretty crazy, so, all right. Prices look pretty crazy. We should, I think the discussion goes down to, and you would expect that. I mean, that's pretty much specialty equipment, right?
Yes. It's a
Okay.
niche market.
Niche market. So in your chat, I'm going to ask the final question. So give me, what is the lowest cost industrial machine, industrial grade machine? Let's say, we already said we can do 10 kilowatt. Oh wow, with that one inverter system, the 10 kilowatt system, we're only producing like a couple of kilograms of freeze dried powder. Wow, that's a lot of energy. Okay. Let's take a nominal system. So 10 kilowatts, that's not industrial grade. That's like home scale. That's for home. We're talking then about, let's say, 100 kilowatts minimum. So say 20 kilograms per day, which is very low, right? That's pretty low. So
Yes.
in order to handle anything that's, meaningful, like, would you invest, say, like, say, 20K into 100 kilowatts of PV? Question would be, what's the payback? We should probably look at that, right?
Yes, that's all it matters.
The payback is really critical here. So let's take a look at, if we had an open source machine that can do this, what's our payback? Because I think for the machine itself, we can do way better than an industry standard, and therefore get that cost to the point where the electric PV infrastructure, that's the big capital expenditure. It's absolutely it, right? So we got to look at let's go back to page number 1, and let's look at payback time for a 100 kilowatt system. Okay, page
Yes.
1.
Under.
Yep. So now, payback time for so let's do a couple assumptions there. So one assumption is 20K in PV assumes 20 cents per watt PV cost. Now that's what I paid for. I got 100 kilowatts for here for the hangar. That's what
Yes.
we're going to install. I paid 20K. So let's assume that's realistic. Let's assume I also looked at inverters. What if you want to get a 100 kilowatt inverter? I found one that was. And feel free to put in Google it and for inverter, that's a 100 kilowatt inverter. Feel free to put in links.
Yeah. I was the 20 cents that you wrote there.
Mm-hmm.
20 cents. Why 20 cents if we talk about 0.02, 0.01?
Yeah, 20 cents per watt. In other words, if it's 20 cents per watt, that's $200 a kilowatt.
And that's the investment cost, correct?
Yep.
Okay. Not the operation cost.
20K in PV for 100 kilowatt
Okay.
array. Right there. Let's say we do 10K inverter. So let's say we got 30K in it, and plus wires and racks. Let's assume that we co-locate this, so that's not going to be prohibitive. It's not going to be close to that in cost. You can get fat pipe, like 4/0 wire, like we just got. That's like a couple of dollars per foot, plus wires, plus mounts. But mounts, you can make this actually part of your building, so you got a free roof. So like I'm not really counting mounts. Assuming you build a building, right? So we're not really counting building costs and everything else. Let's assume we put it on another. Do you have a number of buildings at your? Do you have any excess buildings at your place, like big barns?
Yes, there's some infrastructure that could be adapted.
Yeah. Or we use that for your shading for your blueberries, whatever we
Yes.
do. So assume that doesn't. We're not going to count that mounts and wires for now. So production, daily electric production. 800 kilowatt. 800. So you got 100 kilowatt hours times 8 hours. You got 800 kilowatt hours per day.
I'm looking at the inverter here.
Yep.
What's the specifics I should be looking for?
So
I'm asking.
give me a 100 kilowatt inverter. 100 kilowatt. You got to handle all that power you got.
Okay. I see some called pure sine wave inverter.
Yeah.
Is there any difference on what is applied here?
I don't think it will matter if it's pure sine versus not, but 100 kilowatts is the important one.
Okay.
100 kilowatts. That's huge. That's industrial scale now, not like your home scale. So 100
Yes.
kilowatt. 800 kilowatt hours per day. Let's assume.
And does it have to be three-phasic, monophasic? It doesn't matter.
Three-phase probably you want. It doesn't matter, but we're just getting average prices right now. Like just for, we'll get to that later. One phase or three-phase could work.
Okay.
So 800 divided by 50. Man, that is insane. You're only making like 16 kilograms of powder per day. Yeah, that's really energy intensive. Okay, that's a good reality check for me here. What? 16 kilograms. I mean, this is more than steel and, and concrete. Like, way more than that. Wait, I don't get it. Can that be so? I mean, steel, look, steel takes a kilowatt hour per kilogram to melt it. And we're
Not
talking here
not
30
sure.
to 60 kilowatt hours per kilogram of freeze-dried fruit powders. That is the most energy intensive, some of the most energy intensive processes on Earth here. Okay.
Yeah,
But,
but does it make sense on cost?
um, well, let's see. Let me review those numbers again in that. Um, Let me just go through that again in your chat. Because, yeah, this is like, holy cow, what a reality check. Um,
I'm finding on the web more 10,000 kilowatt instead of
yeah,
100,000 kilowatt.
that's what I'm saying. That's not a common thing. We're talking out of the norm right now. This is, yeah. I did find one that was 100 kilowatts, but yeah, keep looking. Um, that's true. 10 kilowatts is easy. 100 kilowatts, that's a different grade. That's a totally different animal.
Would it be
Um,
possible to interconnect the 10,000 kilowatt instead?
right. So a 10 kilowatt, if it costs 1,000, then you get 10 of them, and you get
Yeah.
100 kilowatts. So we already know $10,000. I saw one that was for like $11,000 for a 100 kilowatt inverter. So yeah, the price is just pretty much linearly scalable. Yeah, we could do the small ones. We can do modular system like that. Yep. Um, 6 to 10 kilowatt hour. Let me ask it some. So what is the optimum theoretical energy use for freeze drying per kilogram of final fruit?
Here on a page called Mercado Libre, which is like the Amazon from Mexico,
Mm-hmm.
I'm finding about 1,750 for 10 inverters that have 10,000 kilowatt.
Yeah, yeah,
Is it relative to the US prices?
yeah. I mean, it's comparable exactly. And so I just found one that was $1,000 for 10 kilowatts. So yeah, I mean it's comparable. Yours is higher, but I mean this stuff all comes from China.
Yes, probably. So 10,000 watts, it's 10 kilowatts,
Yeah,
and that's in Mexico about 3,500.
USD.
No, that's pesos. When I divided that by 20, so each 10K, it's about 175 multiplied by 10. That's where I got the number 1,750 USD for
Mm-hmm.
the 100 kilowatts. Yes, but that's just one website.
Yeah,
Probably that could be much cheaper if I
yeah.
go into specialized stores.
So the best optimized large freeze dryers are more like 10 kilowatt hours per kilogram. Water
Yes,
removed.
makes more sense.
Ah, but that's per kilogram water removed. That's the thing that's catching us here. You see what I'm saying? That's for the water removed, not for the kilogram of final fruit powder. You see. So, so yeah, the figure is still very high, 30 to 60. No, that's the reality. Holy cow. Okay, if that's the reality, if we get 16 kilograms per day, we get out of the 100 kilowatt array. Now, 16 kilograms of dried powder, I mean, that does make a lot of drink, like say you reconstitute it. But if the price is, we said our price selling price per kilogram is 12.
Well, it isn't 12. If you go online, it's
Mm-hmm.
about 25 even to 40. That's the range that it's sold. And what we're
Uh,
aiming here is highest quality.
mm-hmm.
So I mentioned 12 because my goal would be make it very accessible or
Mm-hmm.
for me to include it at bigger radio on their formulas.
So current industry standard is more like $25 to $40.
Yes,
Now, would you be able to, that is that wholesale price, or that's like consumer price?
that's consumer price. That's what I mentioned, 12 for manufacturing price, but that could be even increased until maybe 18 to 20.
Yeah, you can do that. Like, do you have,
Yes,
how do you do that from 12 to 18 or 20? Do you have
because that
people already willing to buy that at that price?
that's the reality of price that they are getting now.
Okay. You
The cheap
mentioned,
price,
so you're mentioning 12 to be like, okay, we're actually going to reduce the price.
yes, to make it accessible, included more in the products that people uses, food, cosmetics, supplements.
Mm-hmm.
So
Is it,
that yes,
if it's used in cosmetics and other things, like, do they command a smaller price there for those products?
they
It's
command a higher price for those products and those niches,
uh-huh.
cosmetics and supplements.
So is it fair to say that the selling price is going to be 20 then
Yes.
in our calculations? Okay. Um, yeah. So if we're making 16 kilograms per day at $20, that's $320 a day. So still, it's a 100-day payback time. That's not bad.
You got that payback time, but how many processed kilograms?
Yeah. So I'm look at page one. I'm saying daily electric production from your 100 kilowatts is 800 kilowatt hours. And if we assume, let's say, like for the 30 to 60 kilowatt hours per kilogram, we're just taking the middle one, which is about 50. So it's upper range for freeze dry. So if you're using 50 kilowatt hours per kilogram, you're getting 16 kilograms per day out of the 800 kilowatt hours of electricity from your PV. So that's 16 times 20 of powder per day. So 100 days gets you about 30K, 30K gets you back the electricity cost. That's quite attractive still. That's
Very much. 3 months for payback.
yeah, yeah, yeah. So the question is, can you capitalize that kind of thing? Like, can you actually? That goes back to like, can you actually get a contract, assuming that we could produce one of these devices? So, what would it take? Would we have to get to a point where we feel confident? We actually show the person would probably require, okay, show me what you got, and we show them, okay, here's this machine we've got or develop. Do we have to develop it first, or can we go concurrent? You gotta have some. Probably might have to have some product to minimize risk, right? Can we do this in a month? Do a design sprint of a freeze dryer. 1 month.
Yes.
Just you, me, and Chat GPT.
I mean, the market is there. The contact I have is a big supplier of ingredients, and the only constraint would be the price. So if we're working in this and we can achieve a certain specific price, that's all we need.
That's all we need. The question is, okay, let's succeed on a design of this freeze dryer. Do you have okay, so that means stainless steel vessels. Do you have do you have actually mechanics on staff or welders on staff who can actually weld something like a stainless steel tank? Can you actually fabricate?
Yes, I would just need the specifics. What I mean, the dimensions, the geometry,
Yeah, yeah.
and the bridges.
Okay. Yeah, let's so
Yeah.
that'll be good. That'll be good. So let's take a look at I mean the process right now would be to look at ask chat for, okay, give me a list of all the components that go into this device, and let's diagram it out so we have a good way to hook our logic around. So let's diagram it out first, and then let's start asking, okay, what's this component? How much does it cost? And let's see if there's any challenges there, because obviously, so you're gonna have to do. I don't know if it's got like multiple chambers, or is it like one chamber? You do like a vacuum, a freeze cycle, or maybe what's it do? It does a vacuum cycle, then freeze cycle, or how does it work? Do you know? You showed it to me before. Do you remember what this sequence was?
I understand first is the freeze,
Freeze.
then vacuum,
Mm-hmm.
and that's it, right? I mean, you first condensate the freeze to not lose any properties of what you're
Mm-hmm.
doing, and then you take out the water by vacuuming.
Yeah. Piece of cake. It's a piece of pipe with two mechanical elements attached. Great. All right. Now, what are the challenges going to be? So let's start diagramming this out. Before we go there, let me just ask. I was asking chat, so I'm going to ask, what is the lowest cost industrial grade freeze dryer machine in terms of cost per kilogram yield per day? So let's see what chat tells me here. But as it pulls it up, let's start diagramming. So let's just start diagramming this thing out. This is exciting. Let's do a duplicate. So here we just summarize here 100-day payback time. So yeah, that's the kind of figures you always get. And then the question is, can you deliver on a real product that does that? So let's see if we can. So let's duplicate slide. So open source freeze dryer diagram. And it helps. I don't know how you do it, but what I like to do is you start from scratch. You don't look anything up. Just think about it. What do you need? Because we already know a lot of that. So we need a vessel. Let's say it's a round vessel.
And does it need to be exactly that geometry, the vessel? Is there a reason why it has to be like that?
No. We're just saying vessel. It's okay. It's because circles are the most structurally sound things for the amount of metal you use. You can't make it a square because you have corners, and therefore it will use metal for the same amount of strength. So if you talk about vacuums, those things are typically circular.
Okay.
Yeah. Let's assume that, I mean, we're not tied to it. We could find that maybe like, oh, maybe we've got a way to do it where we've got thick metal plates there. We just make a thing that's more like cubical because the vessel might be prohibitively expensive to make or something like that. Like the way I would think about a vessel is, for example, if you could get regular stock steel, like say 1-inch thick plate, and then say you could even line it with some food grade material, that would be another way to go. We have to just explore that question in detail. Like, what's the lowest cost vessel for the function of being food safe and withstanding the vacuum pressures? If this is vacuum, then yeah, the circular geometry is the most resistant to collapsing. Just like, like submarines, right? They're this shape. For the reason that that's the best strength to material ratio you can do. Okay, so we're gonna have a vessel. So let's talk about the different functions. So you definitely have to have a vacuum pump and a freezer pump. So let's say, well, how do we do that? Just say, feel free to edit there, but go with me. But I'm just gonna say, so somewhere there's a pump, probably like with some kind of connection to the vessel. It would probably be, if it's a vacuum, you've probably got something connected connected by some kind of a pipe. So this is our freeze dryer for dummies. So you got a pump, you got a connection to the vessel. And then we can ask chat. Well, since we're already designing this, let's see what chat responded here. Lowest cost. I'm going to share my screen so you can see what I'm looking at here as well.
There's a function on ChatGPT called Add People. Would that work so I can see what you're...
Go ahead. How does that work?
Start group chat.
Oh, add people. Yeah, sure.
And I'm gonna copy the link and put it in the chat, so maybe that's gonna...
Okay, so here's the answer for, let's see where to appear. Okay, so we're at the same.
Yes.
Now,
or maybe you can share yours because you were
let's see, how do I do that? So I go add people to this. Oh, yes, I'm going to add people to this one.
Yes.
Mm-hmm.
Or to the chat you were using of my reference chat. There should be an option on the right upper corner. It says Add People. And then I can start seeing.
Okay, so here's mine.
Yeah.
Take a look at that one.
So it's gonna have. Okay, let's do it.
Oh, so you're actually, I'm seeing whatever you're doing, and now you're seeing whatever I'm doing, right?
Correct. Yeah.
Uh-huh. Okay. So we're saying 60 to 65 USD of capex per kilogram of daily fresh feed capacity. Fresh feed capacity? fresh feed, so that's not that's the wet fruit. But dried fruit, that's going to be like 10 times or 15 times less. Okay, so let's see. Okay, so is the batch size wet fruit or is that dry fruit? I'm not clear here.
Are you typing on the chat?
Yeah, I am. Do you see it?
I see that you're typing now. It's batch size, wet or dry fruit.
Yep, yep.
Yeah.
So that's wet. Okay. Um, okay. So I wanted to find a price, and the bottom line price is so like $60. So we're competing with something like $60 for the best um, industrial freeze dry. It's only 200 kilograms per batch. So it's still very small. I mean, you only get like 15 kilograms per day.
Of final
Yeah.
powder product.
But that's the size we need. We're saying if it's 15 kilograms, that's exactly about the size we want. And we're talking about what? They're saying that that thing is 12,000 USD?
Yes.
That's way different than what we saw before. Let's see. Let's click on that Guanhao machine. Let's see. Yeah, 12,000. That's what it says. It says $12,000. That's like that's dirt cheap. Can we just get that?
Is that on the US?
Well, that's Chinese stuff, so it's Alibaba, which means what? Probably double or triple the price after import. But if
Now,
it's like if you tell me that's $12,000, I mean that's pretty good. Um, we probably cannot compete with that if that's a real price. But the kind of quotes we were getting before were way more than that. Okay, so it's time to ask chat some more. Okay, so you tell me we can get is that real? Or after import? Because so you were quoting me, they were quoting me like $1 million.
40K. That's what the chat is mentioning. After all the shipping, crafting, import duty.
Mm-hmm. Okay. Well, okay. Because we could probably build it for the 12,000. Yeah. But so yeah, that makes sense. What were the $1 million machines? Multi-ton per day dried output. Aha. Okay. So yeah, those were. Well, so the question is this $12,000 machine? So let's see. Oh yeah, so it could have a 24 to 36 hour cycle. Mm-hmm.
So bigger ones are more efficient based on time and kilowatts used. That's what you got as well.
Um, Probably. I mean, that's typically the case. If your strategy is to experiment, learn, see how orange powder behaves, prove a business model, then this class machine makes sense. If your strategy is if the strategy is bigger than that, like a 24/7 factory, then it's you're in a seven-figure territory.
I mean, the business model is already there. What we are trying to achieve, in my perspective, is reducing at near zero marginal cost
Mm-hmm.
in order to be able to really mass scale this.
Yeah. Now, multi-ton per day, that's much bigger and much more energy. So we have to settle that question. So probably what? How about? Let's see. I would say like the 100 kilowatt scale modules would probably be a good idea. So once again, let's go to the killer of all, which is always the extensive modularity on extensive scalability. So multiple of the unit. For example, what if the pump services now multiple chambers like that? So let's start at 100 kilowatt as a base module. For only 16 kilograms per day. But that's still considerable. Like if you talk about loading 200 kilograms, I mean that's. I think this also gets into this idea of this is not about freeze drying. This is about material handling, really. When you go to the kind of scale we're talking about, and you're talking about, you'd like to do 300,000 kilos
Of powder or fresh?
fresh.
300,000.
Yeah, that's what you told me. You got 300,000 kilograms of grapefruit waste. Is that what you told me?
Yeah, no, I mentioned I had 3 million kilograms per season.
And I counted, and I think you told me 10% waste.
30% waste.
So you got more than that. So you got more. So you got like
900,000. But let's close it into 100,000 as the pilot scale, because we're talking just about my farm, and we want to do this in many farms.
Okay. What do you want? So you want to handle. Would you like to scale to that as fast as possible, ASAP, like tomorrow?
Like yesterday.
Okay. Okay. I like it. I like it. So the realistic number, you got 3 million. So we're talking about close to 1,000,000 kilos. We're talking tractors and materials handling territory. Like
Yes.
loads after loads, and therefore conveyor belts, like all that kind of stuff. So you're talking about a factory farm. Yeah. Um,
Yes.
yeah, we're talking about a serious operation here. Okay, so we got to start designing it now. So if we talk about 100 kW as a base unit, does that ever cut it? Let's go through some numbers here. So let's say we've got this as our basic design. Um, why don't you go right ahead and ask chat in that chat. I'm gonna work on the other one, do a basic calculation for how we can, how much we would need to scale this in order to handle 1 million kilograms per year. Okay, why
Okay.
don't you go into chat and ask, okay, give me the components, main components of a freeze-dried fruit powder system, vacuum pumps, freezer parts, valves, etc. Just chambers. Just start asking for components. So give me a parts breakdown and parts sourcing for all of that. So why don't you ask that, and I'll do the scalability analysis here.
Okay. That's. Can I do it on the share
Yeah, yeah,
chat?
do it in a shared one. I'm
Okay.
going into the work doc to document the scalability here based on 100 kilowatt units. 100 kilowatt modules. And I must say, this could be interesting in a shared content between this and heat pumps, which are still the same thing, which are compressor pumps and heat exchangers. So this is all relevant. Because I think that for the heat pump system today, I asked Chad about sourcing all the components. It looks realistic that we can buy all the components and make an open source heat pump at a comparable price to what you get off the shelf. So that's actually pretty good news, because that means we control that now with lifetime design as opposed to throwaway. So it's relevant.
Yes,
Mm-hmm.
it is.
Are you seeing a share chat thing? Because I'm not seeing the share chat anymore in these things when it's. Does it have a share? Because I wanted to share this chat. Do you see it?
Mm. I'm looking for it, but I don't see the part of
Yeah.
share.
I'm gonna. Maybe I'll leave that since I wanna. I'll leave it because I want to see it. I want to share it.
It doesn't have the option.
Yeah. Hmm.
And on the energy side, I have a question. What would be the right amount to take as one module?
100 kilowatts, man.
100
Standard village
kilowatts.
scale. Standard village scale. So when you talk about villages, 100 kilowatts is it. That's basically like, 100 horses,
Okay.
1,000 people.
Yeah.
It's about 1,000 people energy worth. Nominal. Yeah.
So it's a 100 kilowatts freeze dryer project. That would be a good
Yeah, yeah. So
indicator.
that'll be the module, and then you scale it, and just like power cubes and things, put 10 of them together. So you got a megawatt, a megawatt of freeze drying. So that's how
Yeah.
I think we got to think, and then we get creative on yeah, the small modularity. That's Lego blocks once again.
Okay.
If you talk about efficiency, what if you pack all of them like in a hexagon shape, one in the middle, six of these tubes on the outside. You've got seven of them total. I mean, insulate that for efficiency. You could get the same efficiency as a one big unit. I bet. You know.
Uh, yeah.
Yeah. So that kind of stuff. Yeah. It's gonna be the freeze dryer revolver shape, whatever. Um, did you see that link? I just started that. Did you see it?
On I'm
Click the
looking at that.
link.
Yeah.
Look, we already have an open source freeze dryer. Looks just like that.
I'm opening. Okay. Cool.
Open source in China.
Yeah.
We share their methods. No attribution in the picture. All right. So that's what I'm saying. Like, if we do this, now shrink that up a little bit, shrink that down. So go like that, and then put like, one, two. And the big thing about the scalability part is you don't go into a new regime of some completely different animal when you scale it. So at 10 times the size, it still uses the same components and therefore is just as easy to maintain and so forth.
Makes sense.
Yeah, yeah. So this is our scaled version, like a 7. You got those in a big room. And maybe you still get away with one vacuum pump, like that one single vacuum pump and freezer compressor, or maybe use many more. But yeah, we can play with all that later. Okay, but the basic calculations are
A question about when you share documents like a Google Doc and it's open source, do you leave it open so they can edit, or they
yeah,
just
edit. It's fine with edit. We haven't had any vandalism happen to date.
okay,
Do that until we see issues.
got it. I'll do. Yes.
Mm-hmm, mm-hmm.
And anyway, if there's some changes unwanted, it's a possibility just to rewind. the
Yeah, you
document?
can. You can. There's a version. If you look at my screen here, if you go to version history, like for example, okay, we can name the current version as freeze dryer start, and then in version history, see version history, you can click on any version from before. So here you see the freeze dryer start on the right hand side. You can basically go, you can say restore this version, you know.
Yes.
So you can do all of that kind of stuff. It's got that kind of version history.
Okay.
Yeah. Okay, so here's the simple answer. We need about 25 of those chambers for your 1,000,000 kilograms per year. That's not too bad. Just 25 of them. So if we start
Doable.
with one, if we do one and one works, so here's the 16 kilograms of oranges is 600 kilograms wet. So per year it's 365 times that. So it's 36,000. I mean, that's significant.
So if I sell that 100 kilograms fresh oranges, also understood by wet,
Yep.
by 0.30, that's 30 USD. I get by income. If
How
I
much per kilogram?
0.30 cents USD, that's a farm gate price.
30 cents per kilogram?
Yes. Yeah, that's something fair to say. And if we do this process of freeze drying by 100, we get 16 of final output powder. And if we sell that into 12 USD, maybe more, but let's do this strategy to put it on a very accessible price to make it scalable and making it fast. The introduction into
Yeah.
more in the formulas and into more products. So 16 by 12, it's 192 USD of income. Now, on the farm, each orange, of course, it depends on the volume output of fresh. It's about three Mexican pesos. I'm taking $1 as 20 Mexican pesos. So it would be about mm,
16 cents.
yeah, max 6 cents,
3 pesos. $1 is 20 pesos.
maybe a little less, but let's do that as a reference.
So that's 1/7 of a dollar. So it's about
Yeah,
15 cents.
15 cents of cost. I'm trying
You talk
to
about
make
your cost or sale?
cost.
Your cost is 15 cents per orange.
No, per kilogram.
That's more like it. On farm, wait, when you say on farm, you mean prior to all the logistics?
Yes, prior to harvest,
Mm-hmm.
packing, shipping, exporting duties. So what I'm trying to reference here is if we go to farmers and telling them instead of you doing the whole process of the normal cycle, and I mean the harvesting part, the selection, the packing, the marketing, and the export, what if it goes just directly to this process from fresh orange into the freeze dry process? And that's what I'm talking about the
Holy cow.
price. I'm talking about the cost. We know the price, the alternative of price of the freeze dried kilogram, but yet with the innovation of the kilowatts, I want to know the cost just to say why this is much better regarding economics than doing the fresh orange sale.
Yeah, that's boils down to delivering the device at low cost. There was the other capitalization of the photovoltaics, but based on a payback. What's your model for? Okay, if it's a 100-day payback, what's your financing model uh, for the machines, which say it's 12,000, and then for the PV, which is say 30,000? How do you finance it? You're gonna go to the seller. So you do the first one. You succeeded at the first one, and you say, "Hey, we've got this uh, pre-sale contract, right? That would be fundable."
Correct. But by having just the specific cost and validating what's the real cost of operating, not one is the investment, one is the day-to-day operating cost. I think it's doable. Just having the final sale price, and I mean by a contract. I don't want to be in the open market. I would like to be better a good partner to formulators or ingredient sellers. Where can I access this financing? Could be by the ingredient seller or could be by the bank. Because when I have a contract, the banks is kind of easier to have access to their financing on a bigger scale. The first one, I could do it myself with some savings, but the rest of the scale, I would go with banks.
What kind of terms?
Depends on the return of investment that we get by the calculation of cost.
What percentage do you estimate if we can deliver, say, 3 months payback or 6 months payback? What's the cost of capital there? Like
So
5%?
no, United States is much better, but here in Mexico it's about 9 to 12%. But it depends on the return of investment. By knowing it's going to be just 3 months, there are different terms of financing that could be accessed, and that 9% could be lower. I don't know if 5% like United States, but even a United States bank loan could be a possibility, which I have access to banks there. Is getting the product honestly and getting the specific cost to make it happen, validate the first output of the process, and that's the way to go.
If that thing is, if the cost is, let's look at the numbers, 40, 50, 60, say it's 100K all in. I mean, that's different than $1 million or $10 million.
Exactly.
Yeah, so that could be interesting. All right. Um, so 25 of these to handle all your production. I mean, that's
And
doable. I think there's a clear path. Like 16 kilograms sound like very, very little, but man, this thing is energy intensive. 10 times that of this is 10 times more valuable than steel. you know?
yes,
Yeah. Crazy. Now,
what would be the next step?
yeah,
Good next step for this?
yeah. So what's the next step? Well, we got to just go start designing thing. I wanted to just dive right into the design because, but I mean, we went through all this discussion on understanding the costs. But yeah, the bottom line is design the thing. Just ask Chat GPT. Did you get any parts from Chat?
Yes, I put it in the components on the first slide of the work document. There's a text called components. Number one, components
Oh,
text.
okay.
You click there, it goes to the Google Doc.
Mm-hmm.
There was the answer of the chat. Components per phase.
Link to the source. Link to the source so we can actually mess with it. Because now this is like, yeah, do that. Can you link to the source? Because there's no problem reading the source, right? And then you can then interact with it.
Yes.
Because we have to spank it around to get all the hallucinations out first.
Okay. I'm doing just that.
Now the first thing is I want to look at, give me parts and links. Where are them parts and links? Yeah, cool. The next immediate thing is like, cool, give me parts and links. That's all. That's the thing you got to spank it down to. Like as soon as you see an answer and you don't see a bunch of links, spank it and say, give me them links, give me the sources, because that's the bottom line. Then you can contact those sources and start validating whether those numbers are real. Otherwise, it can you're extending the process to too much hallucination. You know what I mean?
Yes.
Yeah. Because then you can make Chat accountable. It's like, wait a minute, you told me this could be like really feasible, but this number doesn't show that, right? So that's where you can get and Chat works well like that. You give it very very specifics, and it gives you it corrects itself. Yeah, but it's good. It's good news. Did you know that I got positive news? So I did my first FreeCAD workbench using Chat. It's amazing. It just tells you how to do it. It gives you all the codes. So I basically put in buttons. It was just a text button, but I generated a cube and a circle by hitting buttons. So it took me 30 minutes to do that with a modified menu within FreeCAD in a new workbench called OSE House Designer. So
And you macros as well. That you did the
it
same
did
process.
it. It did it partly through macros, but it actually throws code back onto the back end into the actual mod folder in your FreeCAD directory. So yeah, it actually I messed with stuff on my computer because it gave me the code. It's cool stuff. It's a game changer. It's good. Thanks for teaching me that from
No,
FreeCAD.
thank you. I've been growing a lot by your mentorship.
Love it.
For it was a great half year. I'm really hoping for next year to make all this happen. I
Yeah. Very exciting time, man. Like, yeah, I mean, your economic case is driving me for like, okay, here's some hard hitting economics. And that's what I'm trying to do for OSE right now. It's like, okay, what are the most important things we can do? I mean, we can buy things now, like whatever, the 3D printer infrastructure or CNC torch table or this and that. We got to just be strategic and go for just very specific economic return. But that return also means, like I mentioned, it means getting people on board. That's our primary source of capital. That's going to make this happen, because I can talk all about this, but without the people, this is nothing. So everything I'm designing is okay. It's got to be a social process, a group-based process, because we need a lot of energy on this. And as you're saying, yeah, we're just getting started. I think it's very exciting. I think what we're doing is very exciting. So,
By making money, not throwing away food and making a valuable ingredient, by making money turning salt water into usable water, and at last by making money into building infrastructure to grow food in land that is not really made for food, and I mean in deserts
mm-hmm.
like the pot. I think that's inspiring, that's a possibility, and that's something that will make many communities be able to make money. So I mentioned money three times with the three projects, because at the end, many of the humans that don't see feasibility in these kind of systems, and I'm talking about open source and sharing and creating stuff from nothing.
Yeah.
That's what, in my perspective, and I mentioned once a few calls ago, will take these people that is hungry for change.
Mm-hmm.
So 2026 would be the year to show this. And I believe that at least at the end of the year, at next 27, we can have a big group of people hungry
Oh,
for change. That's my goal too.
awesome. No, thank you. I mean, man, this is great. I love it. Um, it's it's amazing what's happening right now. Is all I can say. Yeah. Also also the rate expansion just with the AI stuff coming online. That
Yeah,
is, man, that's amazing. Because like right now, I feel like we can, just like with the FreeCAD workbench, did it in a half hour. Whereas the last time it was one of our guys who did this big instructional, it was all heavy, and it's like it would take me a week to ever parse it. Now, with AI, it's like you can do things way faster. And I think, man, for this freeze dryer thing, let AI do the work. We do the part of vetting it and correcting all the hallucinations, but the amount of stuff it already does by just getting us at those right sources is just tremendous amount of work that's already accomplished that otherwise takes hours and hours. So yeah, like in this session, we're able to track down a few things already. So it's like the rapid pace, and we got to think always how uh, you know in the apprenticeship, I mean, AI is going to have to be central, just like we were interacting with chat during this call. Imagine scaling that process and then also taking that to real physical prototyping infrastructure and all that. It's very exciting. So just before, like yesterday, I was working on CNC sawmill based on the RepRap 3D printer controller. It's like, whoa, I can literally, so basically chat can get me all the modifications using the identical stuff as the printer, but now connected to actually controlling a full scale sawmill. And then,
yeah,
it showed me, okay, here's how you modify the menus. It also let me know that no way you'd want to start this from scratch, because code like Marlin, that's the firmware for the 3D printer, already has done 10 years of development. So chat told me, I'm like, well, chat, you're pretty smart. Why don't you just write it from scratch? And said, no, that would still take a lot of effort to recreate it. So we're gonna build. Chat told me we're gonna build on the Marlin open source 3D printer firmware, because it's already done all that development. So that's pretty cool. That's kind of a cool thing. I got a chat to understand how complex actual code writing is and how easy it could be to apply things that already exist to new applications. Yeah. So anyway, lots of cool things happening.
that's the beauty of open source,
Yeah. Yeah.
that you
Yeah.
can really understand everything and build from there.
Yeah, exactly. Economic time binding at its best. And yeah, I mean, I think the whole world has to wake up to that. So I think we're leading some of the fundamental work that's going to get this civilization to it. So I love it. And the
Very
fact,
grateful. Yes,
yeah, yeah, absolutely. And the fact that you have a real, I mean, we're not talking about, I'm going to start a business. You've got a successful working operation that's, significant and that you're actually interested in. And that's the most fascinating. And I think that's a lesson for all those other people that could potentially be doing what you're doing. If anybody else catches on that, it's going to be an explosion. You know what I mean? So I think your proof point that you can show, okay, this is open source economics. Here's a real operation. Here's how we make it explode. You know, that's a huge proof
yeah.
point.
And three topics I love: stop food waste, create more water access, and basically integrate food production into areas that they didn't have the opportunity.
Yeah. And believe it or not, it's even at, if we do your techniques for the food growing, like right here, you could have, okay, we've got all this land. There's enough water, but if blueberries can't grow here, well, using this system, we could actually make blueberries grow here very well in the same system that you're designing. So I actually look forward to that because blueberries, this is not a particularly great area for blueberries, but now with what we're developing, it could be. Yeah,
I yes.
yeah, awesome stuff. All right, so here's to 2026. We're going to celebrate major success. Let's see where we are at the end of 2026, and I look forward to it.
Me too. Are we meeting next week
Yeah,
because of New Year and that stuff?
yeah. Let's see. What's a good day next week? What's the schedule looking like there?
I'm open. I
Oh,
mean,
New Year's. You want to just keep it. Oh yeah. You want to? I mean, you just want to do the first, the Thursday. You okay
if
on that?
you're, yeah, I'm open to any
Yeah,
day.
yeah. Thursday's fine. Um, yeah,
Good.
sounds
Let's
good.
do it.
Let's do it, man. Okay. So thanks.
Thank you
We'll
so
we'll
much.
keep talking.
We'll do. Yes.
Take
Bye.
care. Wait, hold on. Assignment for
Yeah.
next time.
Tell me.
What are we going to get to for next time? So why don't you continue just getting us as much detail on very specific price lists for all the components that go into a scale of a system similar to what we saw there, which was like around 200 kilograms of wet fruit, or about, say, around 20 kilograms dry. So based on that basic kind of 100 kilowatt nominal, use that as your energy input because we know that gets about 16 kilograms out. So that's our nominal scale. But let's now start selecting real components for that kind of a system. And what we'll find out is, okay, well maybe that's the way to go and perfectly fine. You do this scalable around 100 kilowatt modules, or maybe we need to go possibly larger. I don't think it probably will be smaller given the energy intensity of this process, but I think we've got somewhat of a sweet spot. But if it might be bigger or a different size, we have to go to that just based on the economic analysis for extensive scalability. We just multiply the units. So I have to see what makes most sense. But let's shake down the 100 kilowatt values, like what are the costs for all those components there, and next week we can have a good estimate to see how close we are to that whatever $12,000 China machine, and see if there's opportunities to beat that or whatever. Hmm.
I'll have the spreadsheet ready with real components and real prices.
Yeah, that sounds good. And refer always, yeah, link it to the chat so we have all the source so we can evaluate it and all of that. Okay.
I'll do this. Yeah.
See you next week.
See you.
Okay. Bye bye.